In this video, we will solve the problems from exercise 3.3. Question number 1. Find the values of sine 480. So let's solve one by one. So let's take the first one. So we have sine 480 degrees. Now we can rewrite 480 as 360 degrees plus 120 degrees. So when it's 360 plus 120, we can eliminate the 360 because 360 is one full circle. So that will be equal to now sine 120 degrees. Further, the sine 120 can be written as sine 90 degrees plus 30 degrees. So this is sine 90 plus theta. And we know that sine 90 plus theta is equal to cos theta. Therefore, sine 90 plus 30 would be equal to cos 30 degrees. And we know cos 30 degrees is nothing but root 3 by 2. That's the answer. Now let's go to the second problem. The second question is find sine minus 1110 degrees. We know that sine minus theta will be equal to minus sine theta. So this is minus sine 1110 degrees. So which is equal to, you can further break this 1110 as 3 full cycles of 360 plus 30 degrees. So this will become minus sine 3 times 360 degrees plus 30 degrees. So this is nothing but, you can eliminate the 363 times and this becomes minus sine 30 degrees, which is equal to minus of sine 30 is 1 by 2, 1 by 2, and that's the answer for the second question. Question number 3. The third question is cos 300 degrees. So cos 300 degrees can be rewritten as 360 minus 60. So this is cos 360 degrees minus 60 degrees. We know that cos 360 minus theta would be cos theta. So this is equal to cos 60 degrees, which is equal to 1 by 2. Question number 4. Tan 1050 degrees. Now we can write tan 1050 as 3 cycles of 360 minus 30 degrees. So 3 times 360 degrees minus 30 degrees. So which is nothing but, we know that tan 360 minus theta will be minus tan theta. So this is equal to minus tan 30 degrees. And tan 30 degrees is 1 by root 3. So it's minus 1 by root 3. Question number 5. Cot 660 degrees. So we can rewrite 660 as cot of 360 times 2, which will be 720, minus 60 degrees. So we know that cot of 360 minus theta is minus cot theta. So this will be minus cot 60 degrees, which is equal to minus 1 by root 3. Question number 6. Tan 19 pi by 3. So here in this case, let's convert the pi to degrees. So this will become tan 19 into 180 degrees by 3. So further simplifying this will become tan 19 by 3 into 360 by 2 in degrees. So this is equal to, we can rearrange 19 by 3 into 2 as 19 by 6, which is nothing but 1 by 6. So this will be tan 1 by 6 into 360 degrees. So further, we can rearrange 1 by 6 as 3 times of 360 degrees plus 1/6 of 360 degrees. So it's tan 3 times 360 degrees plus 360 degrees divided by 6. So this can be rewritten as tan, we can eliminate the 360 here, 3 times 360, and 360 by 6 would be equal to 60 degrees. So this is tan 60 degrees, which is equal to √3. Now for the last question, which is sine minus 11 pi by 3. So we can take the minus out because minus theta. So this will become sine 11 pi by 3, which is rearranging or replacing pi with 180 degrees. This becomes minus sine of 11 into 180 degrees divided by 3. Further simplifying this will be minus sine, and we can rearrange our 180 as 360 divided by 2. So this becomes 11 by 3 into 180 becomes 360 degrees divided by 2. Further clubbing the denominator together, you can write this as minus sine of 11 by 3 times 2 is 6 into 360 degrees. And further, you can separate 11 by 6 as minus sine into 2 minus 1 by 6 into 360 degrees. So this will become minus sine 2 times 360 degrees minus 360 degrees divided by 6. So this can be rewritten as minus sine of 2 times 360 degrees minus 60 degrees. So here we can eliminate the 360, and so you have a minus here. So this becomes minus of, because sine minus theta would be minus again here. So minus sine 60 degrees. So which is equal to √3 by 2. Question number 2. 5 by 7, 2 √6 by 7 is a point on the terminal side of an angle theta in standard position. Determine the trigonometric function values of angle theta. So what you're given here is the coordinate. The coordinate, which is 5 by 7 and 2 √6 by 7. So this means that the length here is 5 by 7, which is the x-axis, and the height here on the y-axis is 2 √6 by 7. Now we can define this as the center O, and this can be a point P, and let's define this point as N, and this will be a right angle. So if you look at this triangle ONP, then since it's a right angle triangle, we're given two sides here, so we can find the length OP. Therefore, in triangle ONP, OP squared is equal to ON squared plus NP squared. So which is, our ON squared is 5 by 7 the whole squared plus NP is 2 root 6 by 7 the whole squared, which is nothing but 25 by 49 plus 4 times 6 will be 24. So this is 24 divided by 7 squared is 49, which is nothing but 49 by 49 and is equal to 1. Therefore, our OP is equal to 1. So, this is the angle theta, because the question says that this point on the terminal side of an angle theta in standard position. So, this angle here is theta. So, we are asked to determine the trigonometric functions. So, let us find sine theta first. So, our sine theta will be equal to opposite side by hypotenuse, and opposite side is NP. So, it's NP divided by OP. NP is nothing but 2 root 6 by 7 divided by 1. So, the answer will be 2 root 6 divided by 7. Similarly, our cos theta would be equal to adjacent side, which is ON divided by OP, the hypotenuse. So, this is nothing but 5 by 7 divided by 1, and that's equal to 5 by 7. Then our tan theta is equal to the opposite side by adjacent side. So, that will be NP divided by ON, and which is 2 root 6 by 7 divided by 5 by 7. Our 7 and 7 will get cancelled. So, the answer will be 2 root 6 by 5. Then, our cot, we will find the cosec theta next. The cosecant theta is nothing but 1 by sine theta. And our sine theta is 2 root 6 by 7. So, this is 7 by 2 root 6. Then, our secant theta will be equal to 1 by cos theta. And our cos theta is 5 by 7. So, secant theta will be 7 by 5. And our cot theta will be equal to 1 by tan theta. So, that is, our tan theta is 2 root 6 by 5. So, our answer would be 5 divided by 2 root 6. So, those are the trigonometric functions, values of angle theta. Question number 3. Find the values of other 5 trigonometric functions for the following. Question number 1. Cos theta is equal to minus 1 by 2, where theta lies in the third quadrant. So, we are given that theta lies in the third quadrant. So, let's solve the first question first. So, given cos theta is equal to minus 1 by 2 and theta lies in the third quadrant. We know that tan theta and cot theta are positive in the third quadrant. Okay, so what we're given here is our cos theta is equal to minus 1 by 2. So, this is our theta, the angle theta. Cos theta is adjacent side by hypotenuse. So, adjacent side is 1, this side is 1. So, if we define this as, let's say, A, B and C, BC, which is adjacent side, will be 1 and the hypotenuse is 2. Okay. So we need to first find AB. So in triangle ABC, AB squared is equal to AC squared minus BC squared. So which implies AB squared is equal to 2 squared minus 1 squared, which is 4 minus 1, and that is 3, which implies AB is equal to root 3. So our AB is now root 3. Now we can find all the rest of the trigonometric functions, provided we apply the condition that is in the third quadrant. So our tan theta and our cot theta will be positive. So sine theta will be equal to opposite side, which is root 3 by 2. But we know the third quadrant sine theta is negative, so it's minus root 3 by 2. Then our cos theta is already given as minus 1 by 2. Then our tan theta will be equal to, it's positive, so which is opposite side by adjacent side, which is root 3 by 1, which is root 3. Then the reciprocals of these functions are cosec theta, which is 1 by sine theta, will be minus 2 by root 3. Then our secant theta, which is the reciprocal of cos theta, will be minus 2. Minus 1 by 2 to the reciprocal will be 2. Then cot theta is equal to reciprocal of tan theta, so that will be 1 by root 3. Question number 2. Here we are given cos theta is equal to 2 by 3 and theta lies in the first quadrant. So in the first quadrant, all trigonometric values are positive. Okay, so let's apply on this triangle. Let's consider this to be triangle ABC, and this is angle theta. So cos theta is adjacent side by hypotenuse. So adjacent side is BC. So this is 2, and the hypotenuse is AC, which is 3. Therefore, in triangle ABC, AB squared is equal to AC squared minus BC squared. So which is 3 squared minus 2 squared, which is 9 minus 4, and that is 5. Therefore, our AB is equal to root of 5. So we have found AB to be root of 5. Now let's find all the trigonometric functions. So sine theta will be equal to opposite side by hypotenuse. So that is root 5 by 3. We know that all the trigonometric values are positive because it's in the first quadrant. So cos theta would be equal to adjacent side by hypotenuse, which is already given to us as 2 by 3. Similarly, tan theta is equal to opposite side by adjacent side. So that is root 5 divided by 2. Next, the reciprocals functions, which is cosecant theta would be equal to 1 by sine theta. So it is 3 by root 5. Then secant theta is equal to reciprocal of cos theta. So it's 3 by 2. And cot theta is reciprocal of tan theta. So it is 2 by root 5. Question number 3. Given to us sine theta is equal to minus 2 by 3 and theta lies in the fourth quadrant. We know that cos theta and secant theta are positive in the fourth quadrant. Okay, so let's define this as triangle ABC, which is a right angle triangle with angle theta, and we're given sine theta is equal to -2/3, which is opposite side will be AB, 2, hypotenuse will be 3. Therefore, from triangle ABC, BC squared is equal to AC squared minus AB squared, which is equal to 3 squared minus 2 squared, which is 9 minus 4, and that is 5, which implies our length BC is equal to root of 5. So BC is defined as root 5. Now let's find our trigonometric functions. So given sine theta is equal to -2/3. Now our cos theta would be positive in the fourth quadrant, so that would be equal to adjacent side, which is root 5 over 3. Then our tan theta would be negative in the fourth quadrant, so it would be minus opposite side by adjacent side, so 2/root 5. Now the reciprocal trigonometric functions, so cosecant theta would be equal to -3/2. Similarly, secant theta will be equal to, it's positive, 3/root 5, and our cot theta will be equal to -root 5/2. Question number 4. Given to us tan theta is equal to -2, and our theta lies in the second quadrant. So we know that sine theta and cosecant theta are positive in the second quadrant. Okay, so let's define now this triangle ABC. What is given to us is that tan theta is -2, so we can say that our opposite side is 2. This is theta here. Then 2/1, so adjacent side will be 1. Therefore, from triangle ABC, AC squared is equal to AB squared plus BC squared, so equal to here, so which is equal to 2 squared plus 1 squared, that is 4 plus 1, which is 5. Therefore, AC is equal to root of 5. So AC is now defined as square root of 5. Now let's find the trigonometric function values. So first the sine theta. Sine theta will be positive because it's the second quadrant, opposite side by hypotenuse, so it is 2 divided by root 5. Cos theta will be negative in the second quadrant, adjacent side by hypotenuse, so 1/root 5 with a minus here, and tan theta is again negative in the second quadrant, which is opposite side by our adjacent side, which is already given here as -2. Then the reciprocal functions, cosecant theta will be equal to root of 5/2. Cosec theta will be positive in the second quadrant. Then secant theta is equal to -root 5, which is reciprocal of cos theta, and it is negative in the second quadrant. And our cot theta is equal to -1/2, reciprocal of tan theta, and it is negative in the second quadrant. Now for our fifth problem. So given to us, secant theta is equal to 13 by 5 and theta lies in the fourth quadrant. Now we know that cos theta and secant theta are positive in the fourth quadrant. Let's define this triangle as triangle A, B and C, and this angle as theta. So secant theta is the reciprocal of cos theta, which is, so secant theta would be hypotenuse by adjacent side. So our hypotenuse is 13 and our adjacent side would be 5. So in triangle ABC, AB squared is equal to AC squared minus BC squared, which is equal to 13 squared minus 5 squared, which is equal to 169 minus 25, which is equal to 144. Therefore, AB is equal to root of 144 will be 12. So we have found our AB to be 12. Now let's find the trigonometric function values. So sine theta will be negative because it's in the fourth quadrant, and that's given by opposite side by hypotenuse. So minus 12 by 13, and our cos theta will be positive, and that will be 5 by 13, and our tan theta will be also negative, and it is opposite side by adjacent side, so it's minus 12 by 5. Now our cosec theta will be equal to minus 13 by 12, and our secant theta will be again positive, that will be 3 by 5, and our cot theta will be negative, that will be minus 5 by 12.
Thank you for watching Maths Tutorial Anand. Please like, and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.